Hello everyone, very good evening and welcome to the BYJU'S Exam Prep. Now, let me know that sound quality, picture quality, everything is fine. And then we are going to start what MOSFET biasing and stabilization, right? As well as we will discuss BJT biasing and stabilization. And that is very important topic for coming exam, that is GATE 2023. Yes, and it is important for electronics, electrical and instrumentation branch. Now try to solve some question on that. Okay guys, so first of all let me know that sound quality, picture quality, everything is fine. Yes please. Okay, then in this session we will discuss different types of biasing of BJT as well as MOSFET, and I will give you the idea which type of questions they may frame on these topics. Okay, complete revision of BJT and MOSFET biasing. Let's start. First of all, this is my small introduction. Myself Sanjay Rathi. I am having around 21 plus years of teaching experience and I have qualified and selected for engineering services exam. In 2005 my rank was 16 and in 2008 my rank was 21. I have mentored more than 1 lakh students for these competitive exams. So Mohan, how are you? Very good evening. Ashok, Satya, जरा एक बार आप लोग भी शेयर कर लीजिए लिंक और साथ में चैनल सब्सक्राइब कर लीजिए. ओके गाइज, तो चैनल फटाफट सब्सक्राइब कर लीजिए. और अब देखते हैं जरा, ये देखिए, दैट इज वन इंपॉर्टेंट इंफॉर्मेशन फॉर यू. 90% scholarship on preparation program. That is a golden opportunity. On 10th December at 8 p.m. You can register on our app, that is the BEP, BYJU'S Exam Prep, or you can go through the official website and register for this scholarship test. Okay, and that is on 10th December at 8 p.m. Then guys, that is the first question. But before solving the first question, I want to give some basic idea about the biasing and stabilization and different techniques for biasing and stabilization. Okay, तो चलिए देखते हैं जरा क्या क्या है टेक्निक्स, क्या क्या यूज होती है. एंड दैट इज वन टेक्निक. तो टेल मी व्हाट इज दिस फिक्स्ड बायस सर्किट, सेल्फ बायस सर्किट और कलेक्टर बेस्ड बायस सर्किट. फर्स्ट ऑफ ऑल, देन वी विल सॉल्व क्वेश्चन. इट इज अ फिक्स्ड बायस, collector based biased or self biased circuit. Normally in BJT we are doing this type of biasing, fixed bias, collector based bias, or what, self biased circuit. Tell me, this is R1, that is R2, VCC, and that is RE is connected here. And what is the name of this circuit and what is the answer for this particular question? Answer, you are able to solve the question, but what is the name of this circuit? Okay. Now guys, we are having different types of techniques. First of all, BJT biasing technique. Yes, what is the answer given? Ashok, you are giving the self bias circuit and Mohan is also giving the self bias circuit. Yes guys, it is a self bias circuit, right? It is nothing but a self bias circuit. Then when RE is connected here, definitely it is a self-biased circuit. Now we are having the different types of biasing. So first of all, biasing in BJT, that is the quick revision and how we can solve the question on that. So biasing for BJT. First, fixed bias circuit. Normally we are connecting a resistor, RC here, VCC here, and simply VBB here and RB here. If that is a very simple question, then apply the VBE here and find the value of IB. That is, IB is equal to VBB minus VBE upon RB. Finished. Once you will get the IB, you can find the IC. What is the IC? Is equal to beta times of IB. Normally, we are neglecting the reverse saturation current. Okay, तो guys यहां से हम लोग नेग्लेक्ट करेंगे. Okay, then normally that formula is what, 1 plus beta times of ICO, but we are neglecting the reverse saturation current. Get the value of IC and finally get the value of VCE. Get the value of VCE. What is the value of the VCE? VCC minus IC into RC. And here that is the current. Always remember that current is what IC here. Here the current is IB. That is one type of fixed bias circuit. And if this VCE is greater than 0.2 volt, if this VCE is greater than 0.2 volt or VCE is set, then the transistor is in what? Active region. So always check what is given VCE set in numerical. If it is given 0.2 volt, it should be greater than that. If it is given 0.5 volt, it should be greater than 0.5 volt. That is one type of question on fixed bias circuit. So remember, this page is very, very important for you. That is a fixed bias circuit. Second, it is also a fixed bias circuit. It is also a fixed bias circuit when we are connecting RC here, RB here. Again, it is a fixed bias circuit. Everything will remain same, but only we have to change the formula for IB. The formula for IB will become VCC minus VBE upon what? RB. Right? So here we are connecting the VBB minus VBE upon RB. Here we are giving the VCC minus VB upon RB. So what is the advantage of this circuit over that circuit, everyone? Right. Sir, 0.2, I cannot understand. What is 0.2? Okay, Ashok, 0.2. 0.2 means normally that is given in what? In a textbook, a standard textbook, VC set for silicon is what? 0.2 volt. It is a typical value, that is what? 0.2 volt. This is called VC set, right? If nothing is given, then you can choose this value for silicon transistor. Normally question on what? Silicon transistor, NPN transistor, and that's why I am using the 0.2 volt. Otherwise, in a particular numerical, they will provide you the value of VCE set. Okay? Up to this point, any doubt? Give me 1 minute. Okay then. Then second thing, it is again a fixed bias. Find the value IB is equal to VCC minus VBE by RB. If let the transistor is in saturation, then what is the approach? If the transistor is in saturation, then always remember, set the value at this point VCE set. It is given in the question VCE set. Find the value of IC, and this is called IC set. IC set. And what is the IC set? VCC minus VCE set upon what? RC. Very simple. VCC minus VCE set upon RC. Get the value of IC set. What is the minimum required value of the IB so that transistor will be in saturation? That is given by IB minimum. IB minimum is equal to IC set divided by beta. Once you will get the value of IB minimum, then calculate what? Actual IB. This is the actual IB. In this question, we are calculating the IB by VCC minus VBE RB. In this question, we can calculate VBB minus VBE upon RB. Calculate the IB. If this IB is greater than or equal to IB minimum, then it is in what? Saturation. Or if it is less than IB minimum, then it is in what? Active region. Active region. Very simple. So that is the method. In this way we can decide whether the transistor is in saturation, yes or no. Right? That is the case. Yes, that is the yes, Mohan. In this case, only one battery is connected. But in this case, we are connecting the two batteries, VBB and VCC. Only one battery is required in this circuit, and that is the advantage of this particular circuit. Bilkul sahi. And that is the way, in this way we can check. Now, remember, once the transistor is in saturation, sometimes they will ask overdrive factor. Overdrive factor. Overdrive factor means actually what is the current. If suppose it is in saturation and IB is greater than IB minimum, then definitely the transistor in saturation, So how much time it is greater than IB minimum? Right? IB upon IB minimum. When we are calculating, we are getting the ratio of these two. Okay? And that will give you the idea, overdrive factor, over saturation. If suppose it is 2 times or 5 times or 10 times, then it is oversaturated. Right? It is oversaturated. So that is the answer for this one. So overdrive factor. So that will be the question. Third question is, third type of circuit is, again it is a fixed bias circuit. Here we are providing potential divider. Here we are giving the potential divider R1 and what? R2. And this is the RC, this is the VCC. So that is the circuit. It is a potential divider circuit. So we can solve it by two methods. First, normally students are saying that we have to apply the Thevenin's theorems. What is the Thevenin's? At this point we are applying the Thevenin's and we are finding the value of VTH. What is the value of VTH? R2 by R1 plus R2 into VCC. That is the value. This is the R2, this is the R1, this is the VCC. So we are finding the value of voltage, and this is called VTH, R2 by R1 plus R2 into VCC. And at this point we are finding the RTH. That is nothing but R1 parallel with R2. R1 parallel with R2. That is the RTH. R1 parallel with R2. Once you will get the R1 parallel with R2 and VTH, then in this circuit, this is converted into a simple circuit RTH and or this is the VTH. Already we have solved this circuit. That is the first diagram. Once you will get the VB, you can find the value of IB, you can find the value of IC, and then finally you can find the value of VCE. So that is the one approach to solve this question. Okay, potential divider circuit. Right, it is a potential divider circuit. Any doubt in this circuit? So tell me whether it is a fixed bias or cell biased. Fixed biased or cell biased circuit. This is again a fixed bias circuit because RE is not connected here, so that is a fixed bias circuit. Here we are using the potential divider. Now in a first diagram we are using 2 batteries. In the second diagram we are using 1 battery only. Right? 1 battery. But what is the, why we are connecting this, like why we are using the potential divider here? Simply in this diagram the value of resistor required is very high. Value of resistor required is what? Very high. 1 minute. Okay. And therefore we are connecting the 2 resistor, or normally value of the resistor is 100 kilo ohm and that is the 10 kilo ohm. Normally this resistor is high and this resistor is what? Low. So advantage of this circuit is single battery as well as the low value of resistor is required. Always remember, in IC fabrication it is very difficult to fabricate the high value of resistance. So that is the advantage. Or again it is a second method. No need to apply the Thevenin's. Directly you can solve. This voltage is what? VB. With respect to ground, the voltage at this point is VB. This is nothing but VB. VB is equal to VB, that is the base terminal. You can directly find the I1, you can directly find the I2, and then you can find the IB. So what is the value of I1? VCC minus VBE. In every numerical they will provide you the VB, 0.7 volt R1. You can find the I1. Then you can find the I2. VBE upon what? R2. VBE upon R2. Then the base current will become I1 minus I2. And then you can find the IC is equal to what? Beta IB. And VCE is equal to what? VCC minus IC into RC. Same method. But no need to apply the Thevenin's here. Directly it is a very easy. Right? Okay then. Again it is a fixed bias circuit because RE is not connected. Remember, we can get the direct question on what? Fixed bias circuit. This is one type of question. Second type of circuit is self-biased. Number of question on self-biased circuit. Number of question on self-biased circuit. The most important one, that is the self-biased circuit. Now, which type of questions? Normally they will give one RE is connected here. One RE is connected here. This is RC. This is VCC. And they will provide you the potential divider circuit here. And that's why it is also called potential divider circuit, voltage divider circuit, emitter bias circuit. These are the name of this circuit. This is the case. If that is the case, this is called self-biased circuit. One thing always remember in a particular question, read question carefully. If suppose it is given the beta is very, very large, then no need to calculate the RTH, simply calculate the VTH. So what is the VTH? R2 by R1 plus R2 into what? VCC. And what is the RTH? Already we have solved. R1 parallel with R2. R1 parallel with R2. That is the RTH. Once you will solve the VTH and RTH, then this circuit is simply converted into, here we are connecting the RTH and here we are connecting the VTH. And that is the IB, that is the IC, and always remember this is the IC plus IB. This is nothing but IE, or IE is given by 1 plus beta times of IB, or IC is given by beta times of IB in active region. Finished. Now, if the beta is given in a particular question, then write down the KVL in this loop. When I am writing the KVL, it will become VTH is equal to IB into RB plus VBE plus 1 plus beta times of IB into what? RE. Always remember this IC plus IB is replaced by what? 1 plus beta times of IB. Right? Directly you can get the IB from this. Or if it is possible, then please revise this formula. No need to write the KVL, KCL. We are wasting our time. If suppose we are saving the 10 to 20 seconds, then it will help. So VTH minus VB upon, always remember that is the RB, and this RE is multiplied by what? 1 plus beta times of RE. To use this formula directly use this formula so that you will get quickly you will get the value of IB. Then directly you can find the value of IC. IC is equal to what? Beta IB. But remember, normally students are making some silly mistakes. Now they are finding the value of VC by simply writing the VCC minus IC into RC. That is the wrong approach. That is the wrong approach. Once you will get the value of IB from this, get the value of IC, get the value of IE. But once it is asked, what is the value of VC? Be careful. If it is asked VCE, then write a KVL from this point to this point. KVL from this point to this point. So what is the KVL here? KVL is equal to, means VCC is equal to IC into RC plus VCE plus IE into RE. Already we have calculated the RE, or you can write the 1 plus beta times of IB into RE. It's up to you. Then find the value of what? VCE. And this VCE should be greater than what VCE set. Otherwise, transistor will be in what? Saturation. Transistor will be in saturation. So that is the case. So now that is wrong approach. If suppose you are writing the VCE is equal to VCC minus IC into RC. This is applicable for what? Fixed bias circuit. That is not applicable for what? Self-biased circuit. Remember that. And that's why be careful about the formula. Second, it is asked, if it is asked what is the VC, what is the collector terminal voltage, then you can write VCC minus IC into RC. So correct this formula. Now, So this is a cell bias circuit. Last one, then we will solve some question. Last is what? Collector based bias circuit. In collector based bias circuit, this R is connected between collector and what? Base. This is RC, this is RB, and this is what? VCC. Now tell me, what about the transistor? If this is the supply voltage is connected here like the 10 volt, then what about the transistor? It is in cutoff, it is in active region, or it is in saturation region? Everyone. Now, if the 10 volt is connected, then definitely it is not in cutoff. Not in cutoff, because here the voltage is required is what? VB. If you are saying that it is in cutoff, then IC will become 0, IB will become 0, the current through the RC will become 0, RB will become 0. Voltage at this point 10 volt, voltage at this point 10 volt. It is greater than 0.7 volt, definitely not in cutoff. But once the collector is connected to what? Base. What is the current here? IC. What is the current here? IB. Then what is the current here? Always remember IC plus IB. And that is given by 1 plus beta times of IB. And the collector voltage VC is always greater than base voltage. Why? Because the current is flowing from higher potential to lower potential. Current is flowing from higher potential to lower potential. If the collector is greater than base, means collector junction is reverse bias. This is the NPN transistor. If the collector is greater than base, means VCB is greater than 0, and that's why that junction is what? Reverse bias. Once the collector junction is reverse bias, means transistor is in active region. So that is a simple way to judge the transistor. If the collector is connected with the base, always remember it is in active region. Directly current distribution, proper current distribution. Some students are writing IC here, and again they are making the silly mistakes. The current collector to inside the transistor, that is the IC, this is the IB, and that's why what is the current here? IC plus IB. IC plus IB. Once it is written, then directly you can apply the KVL here. KVL means we can apply the KVL in this path. From this point to this point to this point, this is the KVL. When we are applying the KVL, we can get the value of IB. Directly VCC is equal to 1 plus beta, directly write 1 plus beta times of IB into RC plus IB into RB plus VB. Right? Or you can directly write this formula VCC minus VB, and remember this formula, that is 1 plus beta times of RC plus what? RB. Because the current is 1 plus beta times, so directly you can write 1 plus beta times of RC plus what? RB, and VCC minus VB. Use this formula, no need to write the KVL. Directly use this formula, get the value of IB, get the value of IC. IC is equal to beta IB. Then what is the silly mistake? Again in this question, what is asked here? Find the value of VC. So if it is asked VC, then we have to write VC is not VCC minus IC into RC. VCC minus IC plus IB into RC. Remember that. VC or VCE, because emitter is connected to ground. Emitter voltage is 0. So VCE. So that is the formula, remember. It is called collector base biased circuit. Okay. Collector base biased circuit. Right. So this type of questions generally they ask. Now, so try to solve this one. Okay. What is the answer for this one? What is the answer for this question? Okay. और इस क्वेश्चन को बनाइए और आंसर मुझे दिखाइए. व्हाट इज द स्टेबिलिटी फैक्टर? व्हाट इज द आइडियल वैल्यू ऑफ एंड practical value of the stability factor S? What should be the ideal value? In the circuit shown below, the silicon NPN transistor, normally question is given on the silicon NPN transistor, very high value of the beta. If the beta is very high, no need to calculate the RTH because the current will be 0. The value of R1 is 60 kilo ohm. This is the R1, this is the value is 60 kilo ohm. Then the required value of R2 in kilo ohm to produce the IC is equal to 1 milliampere. मतलब क्या कर रहे हैं, सिंपल क्वेश्चन की लैंग्वेज चेंज कर रहे हैं, मेथड वही है, फॉर्मूला वही है, सब कुछ वही लगाना है, बस जो पैरामीटर पूछा गया है वो बदल देते हैं. तो यहां पर अब आपको R2 पूछ लिया और आपको IC दिया हुआ है 1 मिली एम्पियर. अब एक बात है, इफ द बेस करंट इज 0 then definitely IC and IE are equal. IC and IE are equal. When the beta is very large, base current is 0, IC and IE are equal. IC is given as 1 milliampere, means IE is also 1 milliampere. And you have to find the value of R2. So what is the value of the VTH here? VTH is nothing but R2 by R1 plus R2 into what? VCC. What is the value of VCC? 3 volt. Then we can draw a circuit here. Convert the resistor in kilo ohm. 500 ohm is converted into kilo ohm because it is also in kilo ohm. 60 kilo ohm. Then no need to calculate the RTH because beta is very large, IB is 0. This voltage is what? VBE, and this is what? VCC, that is the 3 volt, and already we have calculated the VTH. Now here the current is what? 1 milliampere. Milli multiplied with the kilo ohm, it is converted into volt, and VB value is 0.7 volt. Then when we are applying the KVL here, you can directly write VTH is equal to VBE plus IE into RE. So VTH what is given? R2 divided by R1 plus R2 into what? VCC. What is the value of the VCC? 3 volt is equal to 0.7 plus 1 into 0.5. That is nothing but 1.2 volt. It will become 3R2 is equal to 1.2 R1 plus 1.2 R2. And that will become 1.8 R2 is equal to 1.2 times of R1. So what is the value of the R2? 1.2 divided by 1.8 times of R1. That is nothing but, this is divisible by 6. 2 by 3 times of R1. What is R1? 60. Directly you will get the 40 kilo ohm. 40 kilo ohm. 40. Yes, your answer is correct, Mohan. That is the 40 kilo ohm. Right. So, but we can save our time. What is the need to calculate the RTH? When the base current is negligible, then what is the drop across the RTH? 0. No need to calculate the RTH. Directly calculate the VTH. Be careful about the calculation and so on. Right. Now always remember, it acts as what? Potential divider. We are putting it one in kilo ohm. Kilo ohm, kilo ohm. Because now they will ask MSQ, multiple select question. Multiple select question. That may be the numerical. They will ask. One answer is what? That the value of the R2 is what? 40 kilo ohm. Second option, because of potential divider biasing, input resistance increases. So Chinmay Roy, tell me, this statement is right or wrong? Because of this potential divider biasing, the input resistance in case of amplifier, when we are solving the low frequency, tomorrow we will solve the amplifiers, and I am going to give you the idea about RE model and pi model. Right? You are going to get the command over that RE model and pi model. Tomorrow we will discuss each and everything about that. But tell me, because of this type of biasing, what about the input resistance? Input resistance increases because of the potential divider biasing. Right or wrong? Increases. I am telling that right, increases. Okay. Remember that this type of questions they may ask in MSQ. MSQ they may ask. Then always remember, suppose here we are connecting the RS and here we are connecting the VS. Everyone try to understand this concept. RE. Here I am getting some input resistance RI. Okay, without potential divider biasing, I am getting the input resistance RI here. But when I am connecting the potential divider here, then it will come parallel to this Ri. Or something is coming parallel to Ri, then what about the resistor here? Definitely Ri dash is less than what Ri? Definitely, initially when there is no potential divider biasing, what is the resistance seen by the Vs? Ri. Now what is the seen? Ri dash. Or Ri dash is, we are connecting something parallel to what Ri, and that's why the input resistance will what? Decrease. Input resistance will decrease, it will not increase. So that is the drawback of this circuit. Okay my dear friends, this is the drawback of this circuit. Okay, so ये है potential. This is the disadvantage of potential divider circuit. Okay, tell me the name of the circuit which is used to overcome this problem. Which is used to overcome this problem. What is the name of that circuit? Yes, MSQ. They may ask MSQ, multiple select question. Last time around 14 question in electronics branch. 14, 1-4. But this time they may increase the number. Well, 1/3 MSQ, 1/3 numerical answer type, and 1/3 what? MCQs. It may possible. Right? MSQ, MCQ, and what? Numerical answer type question. So we to overcome this type of problem, that is called biasing problem. And what is the biasing problem? Potential divider input resistance decreases. So we are using bootstrapping circuit. We are using what? Bootstrapping. Okay then. And because of this potential divider, when we are connecting the same potential divider type biasing in case of MOSFET, here again we are connecting the potential divider. Everyone tell me, what is the input resistance of the MOSFET? What is the input resistance of the MOSFET? Ig, enter it, the gate current enter into the MOSFET is 0. This is the ID. So what is the input resistance for the MOSFET? We are saying that it is infinite. Yes, input resistance is infinite. But we are providing the potential divider biasing here. When I am giving the potential divider biasing, up to this point it is infinite. But always remember, once you are connecting the potential divider, at this point the input resistance will become R1 parallel with R2 parallel with what? Ri. That is infinite. And it will become R1 parallel with R2. That is the answer. At this point, if it is asked here, then always remember R1 parallel with R2 parallel with infinite. And now it will become finite value. So what about the resistance? Decreases. Mohan, this is clear? Decreases. So now my dear friends, in case of BJT, the input resistance up to this point it is in kilo ohm. And that's why we are connecting it is in kilo ohm and kilo ohm. So that it will not affect this resistor. Right? We want to reduce the effect of this. So kilo ohm. We are not connecting in ohm. Always remember, we are not connecting in ohm here. If suppose we are connecting the potential divider in ohm, then what will happen? This will reduce the input resistance. Similarly, watch the diagram of what? MOSFET. For potential divider, normally we are using, it is in the range of what? Mega ohm. Normally we are using in the range of what? Mega ohm. R1, R2, mega ohm. If mega ohm parallel to what? Infinite, definitely we are going to get the resistance in the terms of what? Mega ohm. That is the reason why we are connecting the resistor in a range of what? Mega ohm in case of MOSFET. Okay. That is this type of MSQ they may ask. Okay. So this is simple question. We can get the value of VGS. We can solve this question with the help of potential divider. But what is the use of this? If they are relating this type of questions, they are making the MSQ, this type of MSQ, then it will become very difficult to give the answer. Yes or no? But don't worry, there is no negative marking in MSQ. No negative marking in MSQ. Okay then. So that is the biasing. Now already we have solved. The answer is what? If this is 60 ohm is written wrong. This is the 60 kilo ohm. Normally we are using the in kilo ohm. That is in the range of kilo ohm. Okay. Now, the transistor in the given circuit should always be in active region. Take VC set is equal to 0.2 volt. One student asked what is the meaning of 0.2 volt. That is given in the question, my dear. VC set is 0.2 volt and that is the VBE is 0.27 volt. VBE is given as 0.7 volt. The maximum value of RC in ohm which can be used is, right, ohm. Now watch this. The beta is very, very large, 100. And what about the RB or RS? It is very small. Very small. The base current is very large, collector current is very large, and RC should be very, very, very small. Otherwise, the transistor will enter into what? Saturation. That is the logic. Always remember, if the IB is very large, right, then beta is large, then IC is large, then RC should be small. Okay, otherwise the transistor will enter into saturation. So, transistor in the given circuit should always be in active region. Then, what should be the value of the RC? Okay, how we are going to solve this? Let this is IC, this is IB, and this voltage is what? 0.7 volt. So, directly you can find the IB first of all. IB is equal to 5 minus 0.7 upon 2 kilo ohm. And this is a very large value, 4.3 divided by 2. 4.3 divided by 2 milliampere. What is the value of IC? Beta times of IB. That is 100. 100 into 4.3 divided by 2, that is nothing but, right? So you can solve 430 divided by 2, 215. Please check my calculation. Okay. So that is the value of IC, very large value of IC. Normally we are getting the 1 milliampere, 2 milliampere, 10 milliampere. That is very, very large. Then what is the VCE? VCE is given by 5 minus IC into RC. What is the IC? 215 milliampere into RC. We have to find the RC. That will give you the answer in kilo ohm. Remember, this is in milliampere, no? It should be greater than what? 0.2. Greater than what? 0.2. Okay, just like greater than or equal to what? 0.2. Otherwise, transistor will enter into saturation. So, from this you can find the value of RC. So, RC should be less than what? 5 minus 0.2 divided by what? 215 milliampere. So, answer will be in kilo ohm. Tell me what is the answer. But answer should be in ohm. So, it should be multiplied with the 1000. 4.8 upon 215 into 1000. That is converted into what? Ohm. Very simple question. You have to save the time, right? Divided by 215 and you will get 20.32 and nearly equal to that. Then that is the answer, 22.5. That is the answer. Yes, Mohan, your answer is correct, 22.5. And ohm, only ohm. You can't connect it in what? Kilo ohm. This is only in ohm. Okay. That will avoid the saturation. Now, so this type of questions they may ask. Now, one question from the MOSFET. Tell me, what about the MOSFET here? For the N-channel MOS transistor shown in the figure, the threshold voltage VTH is 0.8 volt. Neglect the channel length modulation effect. When the drain voltage VD is 1.6 volt, the drain current ID was found to be 0.5. If the VD is adjusted to be 2 volt by changing the value of R, new value of ID. The number of times same question, similar type of questions we are getting, right? In this question, right, in this question, if the drain is connected to gate, always remember, if the drain is connected to gate, then directly we can say that transistor is in what? That MOSFET is in saturation region directly. Because once it is connected, the VD will become VG. Then VDS will become equal to VGS. With respect to source, they are equal because source is connected to ground. Otherwise, again, it is equal. Definitely, the VDS is greater than what? VGS minus VT. Once this condition is satisfied, the transistor is in what? Saturation. Transistor is in saturation. Once it is in saturation, then what is the formula? IDS is equal to half of K and dash W by L VGS minus VT the whole square. Now K and dash is mu n COX, oxide capacitance, and W by L is called aspect ratio. We can take this as a constant. Let this is the K times. Sometimes it is also important. Directly everything is constant, it will become proportional to VGS minus VT the whole square. Once it is proportional, always remember you can get the general formula IDS2 upon IDS1. Because it is proportional to VGS minus VT, you can write VGS2 minus VT upon VGS1 minus VT the whole square. So direct formula, we can use this formula. So what is given in the question? There are two cases. In first case, VDS is 1.6 volt. So VD is 1.6 means VDS is also 1.6. And when VDS is 1.6, definitely the VGS is 1.6 because VGS is equal to VDS. In first case, VDS is given as 1.6 volt. Current is 0.5 milliampere. In second case, VDS is 2 volt. You have to find the new value of ID. You have to find the new value of ID. So in this question, we are changing the value of VDD and RD so that we are changing the value of the current, value of the drop across this point VD, and what is asked here, what is the new value of the current. Okay. And VDS is equal to what? VGS. In second case, you have to find the current. First case, we have the value of the current 0.5 milliampere. In second case, what is the VGS? 2. This is the 0.8. It is given 2 minus 0.8 volt. What is the threshold voltage? This is 0.8 volt is given here. Upon, in first case, 1.6 minus 0.8 whole square. Then it will become 2 minus 1.2 divided by 0.8 square. That is nothing but 3 by 2. 3 by 2 means 9 by 4. So what is the value of IDS2? 0.5. 0.5 when multiplied, this will become 4.5 upon 4. 1.125. No need to use the calculator. No need to use the calculator. 1.125 milliampere. So that is the general question on MOSFET. Normally this type of questions are from the MOSFET. Simply drain is connected to what? Drain is connected to source and then yes. So that is the case. Drain is connected to gate and this is in saturation region. Sometimes that is the question on BJT. Once Zener diode is connected here. Yes. Last question. Transistor circuit is given below. The Zener diode breakdown voltage is 5.3 volt as shown. Take base to emitter voltage drop to be 0.6 volt. Base to emitter VB. The value of the current gain beta is. The value of current gain beta is. Right? What is given? Transistor is given below. The Zener diode breakdown voltage is 5.3 volt. Take the base to emitter voltage drop to be 0.6 volt. The value of the current gain beta is. Beta, you have to find the value of beta here. So what is given here? This 0.5 milliampere current is given, that is passed through what? This resistor. This Zener diode means it is passing from the N side to P side, means definitely it is in breakdown region. Then it will allow the current. If it is in breakdown region, then definitely the voltage at this point will become 5.3 volt. 5.3 volt. This voltage is 0.76 volt. It is given the VBE is what? 0.6 volt. If this is 0.6 volt, you can find the voltage at this point, that is called VE. V is 5.3 minus 0.6, that will become 4.7 volt. 4.7 volt, and this is nothing but 0.47 kilo ohm. Convert it in kilo ohm. This is the 0.22 kilo ohm. right? So once you will get the value 0.47 kilo ohm and this is the 4.7 volt, you can find the value of IE. IE is nothing but 4.7 volt voltage at this point upon resistor 0.47, that is nothing but RE. You can find the IE current here 0.47. Check my calculation, you will get the 10 milliampere. 10 milliampere. Now you have to find the value of the beta. Then here we are getting the I1. Now from this point to this point there is a current IB. There is a current IB. So what is the current IB? IB will become I1 minus current through the Zener diode. To find the value of I1, so we can find the value of I1. Voltage at this point is 5.3 volt. So I1 will become 10 minus 5.3 divided by 4.7. So that is 4.7 divided by 4.7, 1 milliampere. Very simple. 10 minus 5.3 divided by 4.7. So 4.7 divided by 4.7, that is the 1 milliampere current. From 1 milliampere subtract 0.5. What is the IB? I1 minus IZ, that is 1 minus 0.5, that is 0.5 milliampere. This is the value of what? IB. Okay. Once you will get the value of IB and one value of IE is here 10 milliampere. What is the relation between IE and IB? IE is equal to 1 plus beta times of what? IB. So what is the 1 plus beta is equal to IE upon IB. That is 10 milliampere divided by 0.5. That is 100 by 5. 100 by 5. This is 20. So what is the value of the beta? 20 minus 1, that is what? 19. 20 minus 1, that is 19. Okay. So this type of questions, right, on Zener diode. Okay. So please revise. Try to solve this. Okay. So 220 ohm is given, 4.7 is given, 5.3 is given here, right? And we have to solve. 19 is the answer for this question. Again on Zener diode, I am giving you one question. Try to solve this one or try to analyze this question. That is this type of. Here we are connecting the RE and then we are connecting the RB here. Right, and from this I am taking the output, and this is the applied voltage VI, this is the RB, and this is the Zener diode. Here we are having the drop VB, and this is VZ. Now tell me, this is which type of voltage regulator? Which type? Yes, Chinmay, your answer is correct. Which type of voltage regulator? Series voltage regulator or shunt voltage regulator? And then if it is in a breakdown region, then what will be the output? What is the current through the RE? And this diagram is very, very important one. That is the homework. Please try to analyze this diagram. In next class, I will give the idea about that diagram also. And tomorrow at 7:30 p.m. if you want to get the command over what RE model or pi model and how to solve the question on amplifier, right, as well as MOSFET, small signal model of MOSFET, and how to get the Thevenin's equivalent resistor or Norton's equivalent resistance, Thevenin's equivalent circuit for the MOSFET, we will discuss, right, directly from the standard textbook. Sometimes they will ask, find the Thevenin's equivalent of the common source, find the Thevenin's equivalent of the common drain, right, Thevenin's equivalent of the BJT, that is the RE model, pi model, amplifier, input resistance, output resistance, voltage gain, current gain, right? So this type of questions. So tomorrow 7:30 p.m. sharp on the same channel. So subscribe our channel, like the session and share the link of this session. Okay guys. Then thank you for attending the session. You are on BYJU'S Exam Prep. Thank you very much and good night.